Let's talk about trigonometry. Now we're going to talk about triangles. We're going to talk about spatial angles. We're going to talk about identities. We're going to solve double angles. Then we're going to solve some equations, and we're going to sketch some trigonometric graphs. Now the word itself, trigonometry, comes from two words like a trigon and metry. Okay, now just the word itself, trigon or try to mean three, metry to mean measurement. Okay, so we're dealing with measuring three-sided shapes. So basically trigonometry is just the measurements of three-sided shapes, and those three-sided shapes are called triangles. Now there are different types of triangles that you're supposed to know under this topic. Number one is what we call a right angle triangle. Allow me to abbreviate or to write the triangle as that. So how does a right angle triangle look like? So let's say this is our triangle. It has a 90 degrees angle like that. Then another type of a triangle that you're supposed to know is what we call an isosceles triangle. Okay, so an isosceles triangle has got two sides equal. Let's say this side and this side. So because those two sides are equal, this makes the opposite angles to also be equal like that. Then another type of triangle that you're supposed to understand is what we call an equilateral triangle. Now an equilateral triangle, it will have all the sides to be equal. So, and you know that the summation of all the angles in a triangle, they add up to 180. Now if all the angles in this triangle are equal, it means this one will be 60, this one will be 60, this one will also be 60 degrees. So those are the angles in an equilateral triangle. Now we've introduced the aspect of angles. You're supposed to understand different types of angles. Okay, an angle that is less than 90 is called an acute angle. Let's say this is our Cartesian plane or our XY plane. Then this angle is like that. So that will be an acute angle. Then an angle that is 90 degrees is called a right angle. So we can just write it like this and like that. So two perpendicular lines coming together, they form or they make what we call a 90 degrees. Then an angle that is greater than 90 but it is less than 180 is called an obtuse angle. Okay, so it can be something like this, then this angle falls in this region. Okay, so it is greater than 90 but it is less than 180. Okay, then there's also what we call a straight angle. Now a straight angle is just something that looks like a protractor. So it's like that, it's just on a straight line. So this is 180 degrees angle. Then there's also an angle that is greater than 180. That one is called a reflex angle. Okay, I can draw something like this, then it forms a reflex. So this will be called the reflex angle. So these are some of the angles that you're supposed to understand. But now, how do we measure angles? Okay, now angles are measured in two units. Okay, there are different two units that we use for measuring angles. You can measure your angles in what we call degrees, which is a common measurement. You can also measure your angles in what we call radians. Now, degrees, you know that a full revolution in degrees, it is 360 degrees. Okay, then this will equate to, in terms of radians, this is, in terms of a full revolution, is just 2 pi radians. Okay, now we can divide by 2 on both sides, just to simplify our expression. Now if we divide by 2 this side and this side, when the 2 divide, I'm just going to remain with pi. On the other side, 360 divided by 2, that is 180. This is a conversion factor that I don't want you to forget. Okay, so you'll be asked to convert from degrees to radians, and you must be able to do that. Okay, let's solve some examples. Let's say you're told to convert 90 degrees. Let's say you're converting to radians, and you're asked to convert, let's say, 90 degrees to radians. So how are we going to do this? So 90 degrees, you're going to get your conversion factor. 180 degrees is just equivalent to pi. Okay, then your 0 and your 0 can divide, and when you do that, 9 into 9, that is just a 1. 9 into 18, that is a 2. So therefore your final answer to just be pi over 2. Okay, another example that we can have is, let's say you are told to convert 240 degrees to radians. So what are you going to do? 240 degrees multiplied by 180 degrees multiplied by, let's say, divided by, you're dividing pi rad on top. Okay, so what are you going to do? Your zeros can cancel. You're going to look for two numbers that can divide into both. If I say 6 into 24, that is like a 4. 6 into 18, that is like a 3. Therefore I'm going to have 4 pi rad, or I'll just leave the rad, divided by 3. So this will be our final answer. So that's how we are going to convert to radians. What about if you are told to convert to degrees? Let's say you're given 3 pi over 4, and you're told to convert it to degrees. Okay, so what are you going to do? You're still going to multiply by your conversion factor. So in this case, it will be pi over 180 degrees divided by pi. And what are you going to do? So your pi and your pi can divide, and you can say your 4 into 4 is 1. You can say 4 into 18, that's 4 goes into 16, so you're going to have 4 remainder 2. Now 4 into 20, that is like a 5. Therefore we've got a 3 multiplied by a 45. Okay, now if I multiply 3 by 5 on the other side, that is like a 15. Then when I multiply 3 multiply by 4, that is like a 12. A 12 plus 1, that is like a 13. So I have 135 degrees. So this is how you solve, or you convert from one measurement, or from one unit of measurement to another. Okay, now you are also supposed to understand what we call trigonometric ratios. Okay, there's what we call sine, there's what we call cosine, and there's what we call tangent. Okay, now in mathematics, we usually, in trigonometry itself, we usually abbreviate sine as sin, then cos or cosine, we abbreviate it as cos, then tangent, we abbreviate it as tan. Okay, so this is very important for you to understand. Then another concept that you should understand is that, what about the opposites of these ones? Okay, so now the opposite of sine is what we call cosec. Okay, the opposite of cosine is what we call sec or secant. Then the opposite of tan is what we call cot or cotangent. Okay, so this is very, very important for you to know. So these are the trigonometric ratios that you're going to be assessed on. Okay, then you're supposed to also understand the concept of what we call quadrants. So if I'm going to draw my, let's say, my x or y plane, let's say this is the y-axis, this is the x-axis. Okay, so they say this is x, this is y. Now, and these are called quadrants because we've divided our xy plane into 4 parts. Okay, let's say this is quadrant number 1, quadrant 2, quadrant 3, and quadrant 4. Okay, now what you should understand is that we say all students take coffee. Now, what do we mean? In the first quadrant, all trigonometric ratios are positive. Okay, then in the second quadrant, only sine is positive. In the third quadrant, only tan is positive, and in the last quadrant, or in the fourth quadrant, only cos is positive. So this is very important for you to know. Okay, now there are what we call special angles. So there is a 30 degrees, there is a 45 degrees, there is also what we call a 60 degrees. So they are special because of their nature. Okay, so now let's start with 30 and 60. So if you have 30 degrees and 60 degrees, so we'll use our equilateral triangle. And what did we say our equilateral triangle is? It's that triangle that has all the sides that are equal. Let's say this is our equilateral triangle. Okay, so let's say that is our triangle. So now what are we talking about? Because all the sides are equal, allow me to give all the the units to be 2 units. Let each side be 2 units. Even this one is 2 units. Now we've said the summation of all the angles in a triangle, it's 180. So this would be 60 degrees, this would be 60 degrees, this will also be 60 degrees. But now allow me to cut this equilateral triangle into 2 sides. Okay, so what am I going to have? If I cut it on the middle, let's say we cut it here, so you know that this one will be 30 degrees, right? And the other one will be 30 degrees. Okay, making that top part to be 60 degrees. So because we've cut our triangle in the middle, allow me to change the units. Okay, so this would be 1 unit and this would be 1 unit for them to make a 2 units. Okay, so now that we have this, allow me just to get the half of this triangle to explain about this, what we're talking about. So let's say this is our triangle. Okay, if this is our triangle, and we've said that this is 60 degrees, this is 30 degrees, this is 2 units, this is 1 unit. Okay, now how are we going to find the other side? Let's call this side as x. Now there's what we call the famous soccer tower. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . And there's what we call the Pythagoras. So according to the Pythagoras theorem, for you to find x, our 2 in this case, it is a hypotenuse. So you're going to say 2 squared is equals to 1 squared plus x squared. Now the 1 and the x is the opposite and the adjacent. Okay, so now let's solve for us to find x. 2 squared, that is just a 4, is equals to 1 plus x squared. Now when I take the 1 to the other side, when I take this one to the other side, it changes the sign. I'm going to have 4 minus 1 is equals to x squared. Now 4 minus 1, it is just a 3 is equals to x squared. Now for me to remain with my x on the other side, I'm going to square root on both sides. Therefore x will just be equals to the square root of 3. So if x is the square root of 3, let's replace where x is. So this is the square root of 3. So now that we've got that, and this will be our 90 degrees, right? Perpendicular. Okay, so now what are we now going to do? Now we're supposed to find sine 30 degrees. We're supposed to find cos 30 degrees. We're supposed to find tan 30 degrees. Then after that, we're also supposed to again to find what we're supposed to find sine 60 degrees. Let me say, yeah, sine 60 degrees, cos 60 degrees, and tan 60 degrees. Let's start with our sine 30 degrees. Now according to our SOHCAHTOA, is that sine is opposite over hypotenuse. Okay, now opposite over hypotenuse, sine of 30, this is our 30, so this is opposite to 30. Okay, it is a 1. Okay, then the hypotenuse, it is this longest side where we have our 2 like that. Then this one will be the adjacent. So opposite to 30, you're able to see that it is just a 1. So I'm going to write 1 over the hypotenuse is a 2. So 1 over 2. Then how are we going to find your cos 30? Cos 30, we are saying cos is adjacent over hypotenuse. Now adjacent to 30, you're able to see that it's just the square root of 3 and the hypotenuse is 2. So therefore cos 30, it is square root of 3 over 2. Then our tan 30, tan is opposite over adjacent. Now opposite to 30, you're able to see that it is a 1, and adjacent to it, it is the root of 3, the square root of 3. So what are we going to have? We're saying opposite is 1, the square root of 3. So this is how we're going to find 30. What about 60? So with 60, sine of 60, this is 60 degrees. Now sine, we're saying it is opposite over adjacent. So opposite to 60, you're able to see that it's the root of 3. So we're going to have the square root of 3 over the adjacent, or the hypotenuse, that is just a 2. Okay, then again cos 60 will be the adjacent over hypotenuse. Now adjacent to 60, you're able to see that it is just a 1 and the hypotenuse is 2. So cos 60, it is just 1 over 2. Then lastly, we're also supposed to find tan 60. Now 60 opposite, we are saying tan is equals to opposite over adjacent. Now opposite to 60, you're able to see that it's a root of 3 and the adjacent is just a 1. So tan 60 will just be the square root of 3 divided by 1, which is just the same as the square root of 3. So this is how you find 30 and 60 That's why they're called special angles. Okay, now what about the 45 degrees special angle? So what are you going to do? For this one, we're going to use an isosceles triangle. Now allow me to draw it in this fashion. Let's say this is then this is the hypotenuse, let's say that is our triangle. Okay, now allow me to say this side and this side are equal. Okay, and let me give them, because they are equal, let me give them a unit of 1, and this one let me give it the unit of 1. Okay, now because these sides are equal, these two sides will be equal, and because I've drawn it perpendicular like this one will be 90 degrees. Okay, then because this one is a 90 degrees, its summation of the triangle should be 180. So from 180 minus 90 that we've already shown here, I'm just going to remain with a 90 degrees. Now this 90 degrees, I've got two angles which are equal, so I'm going to divide it by 2. I'm going to find 45. Okay, so now what do I have? I'm going to write my 45 degrees here, even this side. Okay, so those are the two angles that we have. Now we've got the longest side. We've said this one can be either adjacent or the opposite. This one can also be the opposite if you name it like that. Now we are supposed to find this longest side, which is called the hypotenuse. Okay, then you know that according to your Pythagoras, allow me to call the hypotenuse as x. According to your Pythagoras, x squared will just be equals to 1 squared plus 1 squared. Okay, so x squared will just be equals to 1 squared, is just 1, plus 1 squared is also a 1. So I have x squared is equals to 1 plus 1, that is a 2. When I find the square root of that, x will be equals to the square root of 2. So where there is x, allow me to put the square root of 2. So this is the square root of 2. Now that our triangle is complete, we're going to come back to our SOHCAHTOA. Okay, so now we're supposed to now find the sine 45 degrees, cos 45 degrees, and tan 45 degrees. Okay, so let's start with sine 45. So I can pick any of the two. I can get this one or the other one. Okay, so for our case, let's pick this one. Okay, we'll still get the same answer. So we're saying sine is equals to opposite over hypotenuse. Opposite over hypotenuse. So opposite to 45, you're able to see that it is just a 1. Then the hypotenuse is the square root of 2, or the longest side. So we have 1 over the square root of 2. We come to cos 45. Cos 45, we're saying cos is adjacent over hypotenuse. Now adjacent to 45, it is a 1. The hypotenuse, it is the square root of 2. So I have 1 over the square root of 2. Then I come to tan 45. Tan is opposite over adjacent. Now opposite to 45, it is a 1. Adjacent to 45, it is also a 1. So we are dividing 1 by 1. So I have 1 divided by 1, which will just give me a 1. So these are some of the special angles that you are supposed to understand. Now how do we apply based on the information that we have? So it can be given to find, let's say without using a calculator, it can be given to find cos 315 degrees. Okay, now this is a very, very vital concept. But now for you to be able to solve such kind of questions, you have to meet about 2 conditions. Okay, before we solve this one, you have to know that when you're measuring these angles, number one, you're measuring them with respect to the x-axis. Number two is that you're measuring an acute angle. Now, an acute angle, we've said, is an angle that is lesser than 90 degrees. So these are the two conditions that should be met. Okay, so let's explain that using this example. Now, cos 315 degrees, 315 is not an acute angle. So what are you going to do? So you're going to say 360 degrees minus 315 degrees. So allow me to explain this using an x or y plane. Let's say this is our okay, let's say this is our Cartesian plane. So, and since it's like that, so let's say this is 0, this is 90 degrees, this is 180 degrees, this is 360, this is 270 degrees, then this, it will go back to 360 degrees like that. Okay, now where is your angle 315 degrees going to fall? So 315 degrees is going to fall in this region. Okay, so we said you're measuring this angle with respect to the x-axis, and it should be an acute angle. So initially you're supposed to measure this whole thing. This is a whole angle that you want, but from this angle you're going to get an acute angle. Okay, so in this case you're measuring the angle that is with respect to the x-axis, and you're getting this because that's the angle that is less than 90. Okay, let's maybe explain it another way. If you're in this region, you're getting this angle because this is already an acute angle, it's less than 90. Let's say your angle is in this region, so initially you're supposed to get this angle. Okay, but now this is more than 90 degrees. Okay, it's not an acute angle. So what are you going to do? It means you're getting an angle with respect to the x-axis and an acute angle, so you're going to get that angle. Let's say it is in the third quadrant, it's like that. So the angle that you would want initially, you're supposed to get that, but that is more than 90 degrees, or that is less, it is more than an acute angle. So you're going to get, for you to get your acute angle, you're going to get this angle. So for you to find that angle, it means you're just going to subtract what is on top. Okay, so that was very important for you to understand as we are going on. So let's say now this angle, it is in this region, and we are saying it is 315, and we are saying you're getting this angle. For you to find this angle, you know that a full revolution is 360. That's why we're subtracting 360 minus 315. Okay, and now when you do 360 minus 315, on my end I'm getting 45 degrees. Now 45 degrees, so what you're going to do now, you're going to say this is the same as cos 45 degrees, and 45 degrees according to your special angles that we've solved is 1 over the square root of 2. Now this is our answer, but is this our final answer? First we have to confirm. You remember we said that in the first quadrant all the ratios are positive, then sine is positive in this area, tan is positive, and cos is positive in this region. So we said all students take coffee. Now this angle was in this region. In this region only cos is positive. Okay, because only cos is positive, therefore our answer, therefore it will be a positive. Okay, 1 over the square root of 2. So that's how we're going to solve this question. Let's solve another one. Let's say you're told to find the cos 240 degrees. So what you're going to do, you're going to get your 240. If we're going to draw our Cartesian plane, let me just draw one, then we'll be using this one. So you have 0, you have 90, you have 180, you have 270, and you have 360. So what do we have? We've got 240. 240, it will fall in this region. Okay, so this is the angle that we would want, but we want an acute angle from this, so we are going to get this. But how are we going to get that? It means we have to subtract what is on top, and this is 180. So for us to get that part, we're going to subtract 180. So it will be 240 minus 180 degrees. So what do we have? When we subtract that, I'm getting 60. So what this means is that we are finding cos 60 degrees. Okay, now cos 60 degrees is just the same as what did we find as cos 60? We found that it was 1 over 2. Now 1 over 2 in this case, that is our answer, and we're saying this is in this quadrant. So we get back to our mnemonic, or students take coffee. Now in this region, or in this quadrant, only tan is positive, and that's where our angle is. So therefore our answer now, it will be what? It will be a negative answer. So this case now, the final answer, it will be a negative 1 over 2. So that's how we're going to solve this one. Let's solve another example. Let's say you're taught to find the sine of 300 degrees. So how are you going to do this? 300, it falls in this region, and for you to find an angle in that region, what are you going to do? You're going to say 360 degrees minus 300, and when you do that, you're just going to find a 60 degrees. Now sine 60 degrees is just the same as the square root of 3 over 2. Then you also have to come back to what we've been talking about, all students take coffee. Now in this region, that's where our angle is, and in that region only cos is positive. So because of that, so what we're going to do is we're going to say our final answer, therefore it will be a negative, okay, root 3 over 2. So that's how we are going to find that one. Let's solve another one. Let's say you're taught to find this sine 210. So where is 210 going to fall? 210 is going to fall in this region. So it's going to fall in that region. So allow me to wrap this part. Okay, so it's going to fall in that region. And what do we now have? So we're saying sine 210 degrees. So 210 is going to fall in this region. But now in this region, for you to find an angle in that region, so it will be something like this. So for you to find this acute angle, what are you going to do? You're going to subtract minus 180. Okay, so what are we going to have? We are saying it to be 210 degrees minus 180 degrees. And what are you going to have when you subtract 200 and 180? That is just equals to a 30 degrees. Now a 30 degrees, you know that sine 30 degrees is just the same as 1 over 2. Now look at the quadrant. This angle is in this quadrant, and we are measuring like that. And in this quadrant, what do we know about this quadrant? All students take coffee. In this quadrant, only tan is positive. Because only tan is positive, therefore our answer will be a negative. So we have negative 1 over 2. Okay, let's solve the last question on this one. What if you're given sec, let's say 5 pi over 6? How are you going to solve this one? Okay, So now you have to first convert your 5 pi over 6 to degrees for you to be able to solve it nicely. So we're going to get our 5 pi over 6. So the way we're going to convert this one, you know that our conversion factor is pi over 180 divided by pi, and what are you going to do? Your pi and your pi can divide, so this pi and this pi can divide. 6 into 6 is 1, 6 into 18, that is like a 3, so 5 multiplied by a 30, you have 150 degrees. So because we've got 150 degrees, so this is just the same as sec 5 pi over 6 is the same as 150 degrees. Okay, now that we have that, you know that sec is just the same as the opposite of cos. So this, it just means that this is the same as 1 over cos 150 degrees. Okay, now from this information we have to find cos 150 degrees, and 150 degrees, in which region is it going to fall? You know that it's going to fall in this region, and it's going to be like that. But now in this region, you said you are measuring an acute angle, so you are going to get this angle, and for you to find that, you're just have to you're just supposed to subtract from 180 degrees. So we're going to do 180 degrees minus 150, and this gives us a 30. Okay, so what we have now therefore is what we have is 1 over cos 30 degrees. Okay, now what is cos 30 degrees? So this now will be 1 divided by cos 30 degrees is just the same as root 3 over 2. And how are you going to do that? You're going to say 1 times 2 over root 3. Okay, so now 2 over root 3, 1 multiplied by 2 on top, that is just a 2 divided by root 3, so the square root of 3. So our final answer is, from what we're just from solving, it is 2 over root 3. Now never leave a third down. You can simplify your your answer by multiplying by root 3 on both on the denominator and on the numerator. So on the numerator, I'm going to have 2 multiplied by the root of 3, or the square root of 3. Then when root 3 and root 3 multiply, you're just going to have a 3. So never leave a root down. So this will be our answer. But now, in which quadrant, and in terms of the sign, what sign is it going to carry? We are saying all students take, let's say, coffee, and that is the region in which 150 is, and in this region only sign is positive. We're saying 150, and that is the region in which it is falling. So because it is falling in that region, and only sign is positive in that, is positive in that region. So what does this mean? What this means is that our answer is, since we've converted it we've converted to 150 degrees, which is that, and we converted it to be like 30, so it will just be a negative like that. So that will be our answer in that regard. Okay, then on this topic, it is very, very important that you understand what we call identities. Now from now on, we're going to talk about what we call double angles, half angles, and we'll move on like that. Okay, so what are you supposed to know? So we need to know one equation that will give us all the identities that we are going to talk about, and everything starts from the x or y plane. Okay, so our x or y plane, let's say this is our y-axis and this is our x-axis. Okay, so now what do we do? Let's say we have a point 0, 0. You know that 0, 0, it is this point. This is the y-axis, this is the x-axis. And let's say we want to find this point. Okay, so for us to find this point, and let's connect this point, so 0 to this point, that will be our expression. And let's form a triangle because we're talking about trigonometry. Okay, so because this is on the x-axis, allow me to call the the unit from here to here as x, and the unit from there to there as y. Okay, so this I'm calling it as x, this will be as y, so even the other side will be y. Okay, so now that we've got this, now we have a hypotenuse. If we created, because we've created this triangle, we have a hypotenuse, so this is the y and that the x there, and we've created this, the hypotenuse. Now allow me to call the hypotenuse as r, or to represent the resultant. Okay, then according to your Pythagoras, how do you find this r, the hypotenuse? So we say it is x squared plus y squared is equals to r squared. Okay, so that is very, very important for you to know. Okay, then from this expression, allow me to make r squared to be 1. I want it to have a 1 on that side. Okay, so what am I going to have if I want to have a 1 on the right hand side? I'm going to divide by r squared throughout. Okay, therefore I have a 1 on the other side. Now y squared over r squared can also be written as y over r. Then you put them in one bracket to be squared because both of them are squared. It is the same concept, and that's what I'm going to do. So I'm going to say this is y over r, then this is squared. I've got a plus. Same, I'm also going to do the same with x, so x over r, then this is squared is equals to 1. So this is what we have on the other side. Then according to your your SOHCAHTOA, okay, let's say we made an angle theta in this case as we are moving in that direction. So the theta in this case, it is the angle or the direction that we we made, so, or that we took. So what are we going to have? For you to find your sine theta to just be equals to what? You know that sine is equals to opposite over hypotenuse. Now opposite to theta, you're able to see that it is just a y. So I'm going to put my y here over the hypotenuse. We've said it is r. Then let's find cos theta. Now cos theta, we're saying cos is adjacent over hypotenuse. So adjacent to theta, we're able to see that it is just an x and the hypotenuse is r. So I have x over r. Now from our previous equation, we said that x over r, and we had y over r, and when these ones are squared, they are going to give you a 1. So now you're able to see that x over r, it's just the same as cos theta, and the y over r is just the same as sine theta. So what are we going to do? Let's replace. So when we replace, let me start with the y over r, x over r. X over r is saying is cos theta, so I'm going to have cos theta, then there's squared plus y over r. I'm going to replace with sine theta because they are the same, so I'm going to say sine theta, then squared is equals to a 1. Now allow me to rub the other side. Now when I simplify this, when the square falls inside, or when it distributes inside, it doesn't fall on the angle itself, it falls on the ratio. So what are we now going to have? We're going to have cos squared theta plus sine squared theta is equals to 1. I don't want you to forget this identity. This is called the Pythagorean identity. Okay, so it is from this identity that we are going to derive other identities. Okay, when you know this identity, basically it will be very easy for you to find the other identities. Okay, let's say you are given tan theta. Okay, so now you know that tan, in terms of identity, tan is the same as tan is equals to sine theta over cos, right? Cos theta. Now what happens if I square my tan? So I'm saying it is tan theta. Let's say tan theta will just be equals to sine theta over cos theta. Now if I square tan, I'm going to have tan squared theta is equals to, because I've squared tan, I also square the other side. I have sine squared theta over cos squared theta. Now that I've got that, remember from the previous identity we said sine squared theta plus cos squared theta is equals to 1. Okay, now if I make sine squared theta the subject of the formula, what am I going to have? I'm going to have sine squared theta is equals to 1. When the cos goes on the other side, becomes negative, so I'm going to have 1 minus cos squared theta. If sine is this, I'm just going to replace here. Okay, and when I do that, what am I going to have? I'm going to have tan squared theta is equals to 1 minus cos squared theta over cos theta, cos squared theta. Now that I've got that, I can separate what is on top. I can write it as 1 over cos squared theta minus cos squared theta divided by cos squared theta. Now that I've got that, 1 over cos, we said it's just the opposite of cos, and the opposite of cos we've said it's sec. So I have sec, but now it's squared, so I'm going to say sec squared theta minus, now cos squared theta and cos squared theta, they're going to divide and they'll give us a 1. So this is another identity that you're supposed to know. So what is the identity? The identity we are saying it is tan squared theta is equals to sec squared theta minus 1. So this is another identity that you are not supposed to forget. Okay, let's derive another one. You know that the opposite of tan it's cot. Okay, if tan is equals to sine over cos, what about cot? Cot therefore be the opposite, right? It will be cos over sine. Okay, now let me say I want to square this one as well. I'm going to have cot squared, let me say theta is equals to, I'm going to have cos squared theta as well because I've squared. Okay, so I've got also sine squared theta. Now that I've got this, we're going to go back again to our Pythagorean identity. Okay, so if sine squared theta plus cos squared theta is equals to 1, what are we going to do? If I make the cos squared theta the subject to the formula, I'm going to have cos squared theta is equals to 1. When the sign goes to the other side, it becomes a negative, so I'm going to have negative sine squared theta. So I'm going to replace it on top there, and let's just do that. So when I replace, what am I going to have? I'm going to have 1 minus sine squared theta over sine squared theta, and you're going to go along with the cot squared theta like that. So your cot squared theta therefore will just be equals to, I'm going to separate it as well. I'm going to say 1 over sine squared theta minus sine squared theta over sine squared theta. And what am I now going to have? You know that 1 over sine, it is just the same as cosec, or it's the opposite of sine, and the opposite of sine is cosec. So I'm going to write it as cosec squared theta minus a 1. So this is another identity that you're not supposed to get. So what is our identity? Our identity is cot squared theta is equals to cosec squared theta minus 1. This is another identity that you're not supposed to forget. So, and other identities will follow. So on this topic, or in this concept, what are they going to ask you? They are going to ask you to prove identities. So proving. So probably let's solve an example. Let's say you're given sec let's say sec x minus tan, let's say tan x, sine, let's say sine x is equals to 1 over sec x. Now you are told to prove. So how are you going to prove? So you want to prove that the left hand side is equals to your right hand side. Okay, so in this case, always choose the area that is a bit, you know, that you can easily simplify. So you know that it will be very hard for us to move from this to go to that. Okay, but it is very easy for us to go from this side to find that. Okay, so how are you going to solve? You know that sec x or sec is just the same as, it's the opposite of cos, right? So it is 1 over cos x minus, now tan we've said is just the same as sine, so this will be sine x over cos x. Now it's multiplying by sine x, so you write your sine x as well. Okay, now that we've got that, okay, so you're able to see that we've got the same denominator, and what is on top can multiply. So what are we going to have? So if we solve, on top I'm going to have 1 minus sine multiplied by sine, I'm just going to have a square, so I'm going to have sine squared x over, because I've got the same denominator, I'm just going to get 1 cos x. Now that I've got this, you now you remember that 1 minus sine squared, you know, x is just the same as cos squared x, right, according to your Pythagorean identity. So this is just the same as cos squared x over, now we've got the cos x down. Okay, now we can divide. So we've got a cos down, and when you divide with the 2 that are on top, I'm going to remind with 1 on top. Or what I mean is, because cos squared, it just means cos x multiplied by cos x, then I've got a cos x down. So 1 cos x and 1 cos x are going to divide, therefore I'm just going to remain with the cos x. And cos x, is it the same as 1 over sec x? Yes, they are the same, because one is just the opposite of each of the other one. So therefore we've proven, and you're going to write hence proven. So that's how you solve this one. Let's solve another, let's say, example. So how can you prove, let's say 1 plus cos x over sin x is equals to, let's say, cosec plus cot. Okay, there is x throughout, so cosec x plus cot x. So how are you going to solve this one? So you can either go from this to that or from this to that. Okay, so I think for me to be very simple for me to go from this to that. Okay, so let's solve. So even this one I'm going to split it like we split the other one, so it will be 1 over sin x plus cos x over sin x. And now you know that 1 over sin x is just the same as cosec, right? So I have cosec x plus cos x over sin x. You know that this is the opposite of tan, right? The opposite of tan is cot x. So therefore this will be our final answer, because this is equals to that. Hence proven. Why? Because the left hand side is equals to the right hand side. Let's solve the last question. Let's say you're asked to prove that sec x, let's say sec squared theta over, let's say, sec squared theta minus 1 is equals to, let's say, cosec squared theta. Okay, so even in this one it is very hard for us to go from this side to go in this direction, but it is very simple for us to go from this side to the other direction. So let's pick the left hand side. So you know that your sec squared theta, you can just write it, sec squared theta is equals to sec squared theta minus 1. You know that this is an identity for tan, right? So we can write our tan. So tan squared theta, and we're just from solving that identity. So now that we got that, what do we have? We've got sec x divided by tan x. Sec x or sec theta, you know that sec is just the opposite of cos. So this is 1 over cos squared theta. Now it's divided by tan theta. Tan, and tan is just the same as sine over cos. Now because it's squared, I'm going to say sine squared theta divided by cos squared theta. Now that I've got that, you know that because we are dividing, the symbol is going to change. It's going to become multiplication, and what was the denominator becomes the numerator. What was the numerator becomes the denominator. Okay, so the cos squared and the cos squared theta, they're going to divide. Therefore I'm just going to have 1 on top over sine squared theta. Now is sine squared theta, you know that 1 over sine squared theta is just equals to 1 over sine squared theta is just the same as cosec squared theta, because they are opposites of each other, hence giving us the right hand side. Therefore we're going to say hence proven. Why? Because the left hand side is equals to the right hand side. So this is how you solve trigonometric identities. Okay, so that is very important. Now let's talk about what we call double angles. Now for double angles, so we're supposed to know how to find double angle for each one of them. So we can say sine A plus B. We're supposed to know how to find the double angle like cos A plus B, and for tan, okay, tan A plus B. Now this would mean also the minus part of each one of them. Okay, so let's solve. Let's start with the first one for sine. So how are we going to solve that one? So we are saying double angle for sine. Let's say we've got A plus B. So how are you going to solve that? So the way we are going to solve this, for sine, it will be sine A cos B plus, then you're going to now go to sine B cos A. That's how you solve for sine. So this will be the same if you have a minus. What you're just going to change is a minus there. Okay, so that is very, very important for you to know. Now what if now instead of having A plus B, let me now say you have got sine of A plus A. So how are you going to solve it? It's the same thing. You're going to say sine A cos A, let's say plus, then you're going to have sine A cos A. Now that we've got that, now you're able to see that what you're now going to have is sine. Now A plus A in the bracket is just the same as 2A. So 2A. Now on the other side I've got sine A cos A and sine A cos A. You're able to see that these ones are the same. This is just the same like x plus x. When you have x plus x is just equals to 2x, right? So that's what we're going to have as well. We're going to have 2 sine A cos A, and this is another important double angle for sine that you're supposed to know. It's a very, very important for you to know. Okay, so maybe let's solve an example here on the same sine. Let's say you're taught to find the sine 15 degrees. How are you going to find the sine 15 degrees? Okay, so mind you, you don't have a calculator, so you're going to use your special angles that we've talked about. So which two special angles can you either add, subtract, or anything to give you a 15 degrees? So special angles, we've talked about 45, we've talked about 30, we've talked about 60. So from this list, so if I say 45 minus 30, that will give me a 15. Okay, so that's what I'm going to write. So sine 15 degrees is the same as 45 degrees minus 30 degrees, like that. Okay, so because of that, I now introduce the double angle for sine. So we said if you've got sine A minus B, it is just the same as sine A cos B minus sine B cos A. Okay, so now that will be the thing. So allow us to say 45 is this is A, this is, let's say, B. Okay, so what are we going to have? So in this case, we're just going to separate, to just put them nicely. So we're going to say sine of 45 minus 30 is just the same as, we're going to have sine 45 cos 30 minus sine of let's say 30 cos of 45. So this is what we have. So now our duty is just to solve what we have. You know what sine 45 is? We said it's just the same as the square root of 2 over 2. This is multiplying by cos 30. It will just be the root 3 over 2. Then we've got the minus. You come to sine 30. Sine 30 is just the same. It's just the same as the square root of sine 30 is just the same as 1 over 2. This is multiplying by like cos 45. That is the square root of 2 over 2. Then you just solve. So now on the other side, when I multiply the denominators, 2 multiplied by 2, that is a 4. Then root 2 multiplied by root 3, you know, it just gives me a root 6 minus Now when I come to the other side, 2 multiplied by 2, that will just give me a 4. Okay, when you are dividing 1 multiplied by the root of 2 on top, I'm just going to have the root of 2. So this will be my answer. So that's what you're going to do. Okay, so another thing that you're supposed to know here is so it can also be given something like cos 15 degrees. You know, you're just going to also do 45 minus 30. Let's say you're given tan, let's say 75 degrees. Okay, so you're just going to be playing around these special angles. 75 degrees can be written as 45 degrees plus 30 degrees. It's going to give you that. Okay, and you're just going to apply the knowledge of what we're talking about. Okay, now let's now come to cos. What if you've got cos A plus B? So how are you going to solve for cos? So for cos, okay, you're just going to say cos A, cos B. Now the symbol will change. Here it is plus, so you're going to have a minus. Then you're going to now say sin A, sin B. Okay, so that's for cos. Now like the earlier one that we did, so what if you've got cos A plus A? So if you have cos A plus A, you're going to have cos A minus sin A sin A. Now that you've got that, cos is equals to A plus A in the bracket just gives us 2A. So cos 2A is equals to, now if I multiply cos A multiplied by cos A, that will give me cos squared A minus, if I multiply sin A multiplied by sin A, that will give me sin squared A. This is another identity or a double, you know, angle that of cos that you are not supposed to forget. So let me write it down. We have cos 2A is equals to cos squared A minus sin squared A. Let's call this one as number 1. Cos has got 3, you know, double angles that you're supposed to understand. Okay, why does it call 3? Because you've got cos squared, you get, and the sin squared. These ones you can just replace them using, you know, the Pythagorean identity that we started with. Okay, so let's start with the first one. We are saying cos squared A plus sin squared A is equals to a 1. You remember that identity. Now if I make cos a subject to the formula, cos squared A is equals to 1 minus sin squared A. This is 1 from the parent identity. Okay, then so how are we going to do? Allow me to replace this cos squared into, when I replace it there, I see what I have. So 2, let's call this one as number 2. So cos 2A is equals to, then when we replace this with that, so what am I going to have? I'm going to have 1 minus sin squared A. Then there is a minus, so I'm going to write my minus sin squared A. So how is it this one going to equate? I'm just going to have 1 minus sin squared A minus sin squared A. When I've got that, now what do I have? Mind you, this is not multiplying with this. Okay, it's just normal arithmetic. That's why I just remove the brackets. Then what am I going to have? I'm going to have 1 minus, now sin squared A and sin squared A, they're the same and they've got minus signs, so we're just going to say minus 2 sin squared A. This is the second equation that you're not supposed to get for cos. to forget. Then another one that you're supposed to understand is when we replace now sine. If we're going to make sine squared the subject to the formula in our Pythagorean identity, you're going to have sine squared a is just the same as 1 minus cos squared a, and this is what we're going to replace here, where the sine squared a, to find the third identity. So I'm going to have cos 2a is equals to cos squared a minus, then I replace with the sine squared a, so I'm going to have 1 minus cos squared a. Now that I've got that, I'm going to have cos squared a. When I distribute the negative, what am I going to have? I'm going to have negative 1, then the negative multiplied by the negative cos on the other side, I'm going to have positive cos squared a. Now that I've got that, you know that because I've got cos squared a and cos squared a, I can add these two. So when I add these two, I'm going to have 2 cos squared a minus 1. This is another, identity for cos in terms of double angles that you're supposed to not forget. Okay, so very, very important for you to know. So those are the double angles for cos. Okay, now let's talk about what we call half angles. Now from your half angles, we're going to use the same two formulas that were just from deriving. We had cos 2a is equals to 1 minus 2 sine squared a. Then you have cos 2a is equals to 2 cos squared a minus 1. These are the two double angles that we are just from finding. But now, because double angles, we're saying example cos 2a, you've doubled a, but what if you want to half a? Okay, that's what it means. Instead of having what if you want to now half a? Okay, so that's what we'll be talking about. Instead of having a double one, we are finding the half of it. Okay, so how are you going to find these ones? Okay, so in this expression, let's start with the first one. Let's make sine a the subject. Okay, let's make sine a the subject. Okay, so for us to make sine a the subject, so allow me to take the negative 2 to the other side and the cos to the other side. Okay, so when I do that, what am I going to have? I'm going to have 2 sine squared a is equals to, I'm going to have 1. When the cos 2a goes to the other side, becomes negative, I'm going to have minus cos 2a. Okay, now that I've got that, this 2a is a double angle. So because it's a double angle, what I'm going to do is that I'm going to multiply everything by half. Okay, so because we're talking about half angles, allow me to multiply everything by half. Now if I multiply by half on the other side, you know that 2 and 2, they're going to divide, and I'm just going to remain with sine squared a. So I'm going to have sine squared a. Okay, I'm going to have sine squared a is equals to, then on the other side I'm going to have 1 minus cos the 2 and the 2, they're going to divide. I'm just going to have cos a. Okay, so now what do we now have? What we have here now is let's multiply everything by half again. So if I multiply this by half, I'm going to have, if I multiply everything by half, let me put my half again outside, I'm going to have this side, I'm going to have sine squared a over 2 is equals to 1 minus cos a over 2. Okay, now for me to remain with my for me now to remain the square on the to remove the square on the other side, I'm going to divide by the square root on both sides. When I do that, what I have on the other side to be sine of a over 2 will be equals to the square root of 1 minus cos a over 2. So that is the half angle formula for sine. What about for cos? So we're going to now use the other equation. So for this equation, what am I going to do? I'm going to make cos a the subject. So what am I going to do? I'm going to say 2 cos squared a. When I take the negative 1 to the other side, it's going to be positive. So I'm going to have 1 plus cos 2a on the other side. And because I've got that, I'm going to halve everything. Okay, now when I have everything, I'm going to have 2 cos squared a over 2 is equals to, on the other side, I'm going to have 1 plus cos a, and this is multiplying by 2. Let's say this is your half. Okay, and we're multiplying everything like that. So what do we have? So this side I'm just going to have cos squared a over 2, just like on the other side you have 1 plus cos a over 2. Okay, now for me to remain with the a on for me to cancel the square on the other side, I'm going to square root on both sides. So when I square root on both sides, I'm just going to have cos a over 2 is equals to the square root of 1 plus cos a over 2. So this is about, these are the double angle formulas that you're supposed to know, the half angle formulas that you're supposed to know. So what are we talking about? Sine a over 2, because you've halved a, that's why we're saying a over 2 is just the same as, or it is equals to the square root of 1 minus cos a, or the angle, divided by 2. Then if you're finding cos a over 2, when you're having the cos 1, you're going to have the square root of 1 instead of a minus. Now you have a plus, cos a over 2. So these are the half angle formulas that we are talking about. So that is, it's very important for you to understand these half angle formulas. Now we've talked about double angles for tan, for cos and sine. What about for tan? So what if you've got tan a plus b? Now you know that tan is equals to sine over cos. Okay, and you have theta there. So what are you going to do? So tan a plus b is just the same as tan. So the way we're going to write it is going to be sine a plus b divided by cos a plus b. Now we know what sine a plus b is. We've talked about it in terms of sine. Sine a plus b is just the same as sine of a cos b plus, then you're going to come to the other side, you're going to say sine b cos a. This is going to be divided by, now when it comes to cos down, you know it's going to just be cos a cos b. The symbol changes, we have the minus, we have sine a sine b. Okay, now what we are going to do from here is very interesting. We will divide everything by the denominator term. Okay, by the denominator term. Okay, so this one that is here, so we're going to divide by the denominator term. In this case, we're going to divide everything by cos A cos B. Okay, so allow me to write it here. This will be equals to, so because we're dividing everything, so I'm going to write the first, so I'm going to write sin A cos B. This one, let's divide it by this one here. This would divide by everything, so allow me to write it here. So we're dividing by cos A cos B. Then there's a plus here. I'm going to write the plus, then I have sin B cos A. We're dividing by the same thing, cos A cos B. Okay, we're done in the numerator. Let's come down. Down we are going to have cos A cos B is going to divide by itself, cos A cos B. Then we've got the minus here, so I'm going to write the minus. So I've got the minus, then sin A sin B, I'm going to write it. So I have sin A sin B over what we are dividing by throughout, cos A cos B. Now that we've got this, how is it now going to simplify? Okay, so on top, cos B and cos B can divide, and when they divide, I'm just going to remain with sin A and cos A. Cos sin A and cos A, sin A over cos A, this is just the same as tan A, right? So I'm going to write my tan A. There's a plus, I write the plus. Then when I come on the other side, cos A and cos A can divide, therefore I'm going to remain with sin B over cos B. Sin B over cos B is the same as what? Tan B. Over, I come down, we say this is cos A and cos A, cos B and cos B. This will just give us a 1. Then there is a minus. When I come on the other side, I've got sin A over cos A, sin B over cos B. Sin A over sin A, sin A over cos A, that is just the same as tan A. Then sin B over cos B, that just gives me tan B. So this is the double. Let's say this is how you find it for cos. Okay, okay, so it is that. So what are we saying? Tan A plus B, we're just from deriving it. Okay, is just equals to tan A plus tan B over 1 plus tan A tan B. Okay, is it plus? Okay, so that's what you are going to, actually it's a minus from the previous one. We just found the minus, so this is minus tan A tan B. Okay, so this is the equation. So if you have a minus here, you have a minus here, but you have a plus here. So that's the identity. So what am I saying? If you've got tan A minus B, it will just be tan A minus tan B over, you're going to say 1, instead of a minus, you're going to have a plus now. Okay, then you're going to have tan A tan B. Okay, so that is what I'm talking about. Now what if now you have, instead of having tan A plus A, you have tan A plus A? Instead of having tan A plus B, you have tan A plus A. What are you going to have? It's the same identity, or it's the same way. You're going to say tan A plus tan A over 1 minus tan A multiplied by tan A. Now this one now simplifies to tan 2A. 2A is a double angle, right? So the double angle for tan, now for tan 2A is just the same as when I add tan A plus tan A. Okay, that just gives me 2 tan A over, when I come to what is down, I've got a 1 minus tan A multiplied by tan A. That just gives me tan squared A. So this is the double one, or the double angle formula for tan. So that is very important for you to also understand. Now you're also supposed to know how to solve equations on this topic. We've talked about special angles, we've talked about everything that we're just talking about. Now when talking about equations, let's say you're given cos 60 is equals to 1 over 2. So what this one simplifies to, if I'm going to find the angle itself, 60 degrees is just equals to cos inverse. It becomes the arctan, okay? Cos inverse of 1 over 2. So what do we mean? They give you an equation, cos x is equals to 1 over 2. How are you going to find your x? You're going to say x will be equals to the cos inverse of 1 over 2. Okay, and 1 over 2, we know that is just the same as 60 degrees. Okay, so therefore x will be equals to 60 degrees. So that is very, very important for you to know. Okay, then another thing is let's say they've given you to solve, let's start with the basics. Okay, let's say you are given to solve, let's say you have 2 cos x is equals to 1. So how are you going to solve this one? For you to solve that one, you can divide both sides by 2. And you divide both sides by 2, you're going to have cos x is equals to 1 over 2. Now because you've got that, for me to find x will be equals to the cos inverse of 1 over 2. And the 1 over 2, we know that is just the same as, in terms of cos, is just the same as 60 degrees. Now you have to look at your quadrant. 60 is positive, and in which quadrant is cos also positive? So you come to all students take coffee in the 4th quadrant. So for us to find the angle in the 4th quadrant, so we're going to say 360 minus 60 degrees, and 360 minus 60 degrees, that just gives us a 300. So therefore we've got 2 answers. Okay, you're just not going to write the first answer, you're also going to write the other one. So the other one will be 300 degrees. So those will be our answers. So let's solve another one. Let's say you're given sin 2x is equals to 1 over 2. So how are you going to solve this one? So you're going to say 2x is equals to sine inverse of 1 over 2. Now sine inverse of 1 over 2 is just the same as 30 degrees. So 2x is equals to 30 degrees. Okay, now you've got 2x. Okay, so what are you going to have? So here, that's where it becomes very interesting. So 30 is the first answer that you have. Now, in which quadrant is sign also positive? So all students take coffee. So sign, we've found 30. 30 is in this quadrant. All of them are positive in that, but sign is also positive in the second quadrant. So for us to find the sign in this quadrant, and you know that in this quadrant there is 180, this is 180, so we're going to subtract 180 degrees minus 30 degrees to find the acute angle. So what are we going to have, or to find the angle that we want in this case? In this case, it's going to be 150 degrees. So that is another answer that you shouldn't forget. Okay, so we're going to write 150 degrees. Okay, now we have a 2x. Okay, because it's a double angle, we have to take another revolution. So what it means is that this is our x or y plane. Let's say our 30 degrees, the one that we found was here. Okay, now we took one revolution. Okay, it gave us 30 and the 150. Okay, but now because of the 2x, the 2x would mean that we're supposed to take another revolution. Okay, now as we're taking the second revolution, you know that a full revolution is what? Is 360. So to these two angles that we have, we are going to add 360, or we are going to add 2 pi or a revolution to each of them. So what are we going to have? So to 30, so I'm going to say 30 plus 360. I'm also going to say 150 plus 360. Okay, so what do we have? So on my calculator, 30 plus 360, I'm getting 390. Then 150 plus 360, I'm getting something like 510. Okay, so those are the answers that I have. So I'm going to write them here: 390 and 510. So we've taken our full revolution and we are done. But now we are saying it is 2x, but if they ask you to find x now, because it's an equation, you're going to divide by 2 throughout. Therefore your x will be equals to 30 divided by 2, that is like a 15. 150 divided by 2, that is like 75. 390 divided by 2, that is like 195 degrees. Then the other one is 255 degrees. So these are going to be your answer. Now they're going to give you a range, so the range will be based on what they've given you. If they've given you the range in terms of pi, you have to convert these ones in terms of pi, and we've talked about how you convert, you know, from degrees to radians, okay, or pi. So that's how you're going to solve this one. Now if we had 3x here, that would mean instead of taking, let me mention that as well, instead of taking, okay, so if we had 3x as an example, instead of just having 2x, we had 3x. 3x would mean after taking 2 revolutions, we are going to again take another revolution. So if it was like this, this is our 30. We've taken the first revolution that gave us the 30 and the 150. We've taken the second one that gave us 195 and 255, or let me say it gave us 390 and 510. We're going to again take another one. Okay, so what are we going to do now? If it was 3, so the first revolution gave us this one and this one, the second revolution gave us this one and this one. So the third revolution, if you get the third revolution, we're going to get this one and this one. The answer that we get from the second revolution, we're going to add 360 to each one of them. So we're going to say 390 plus 360. We're also going to get 510 plus 360, and we find the answers like that. So because if we are 3x, we're going to have, instead of having 4 answers like for 2x, we're going to have 6 answers. Okay, so that's how you are going to solve. Let's solve another equation. Let's say sine squared of x is equals to 0.5. So how are you going to solve this one? So you're going to say sine squared of x is equals to, you know that 0.5 is just the same as 1 over 2, right? Or half. Okay, so now what do we do? For us to remain with our sine x, we don't want a square, so we're going to square root on both sides. Okay, so therefore I'm going to have sine x is equals to the square can be on square root of 1 and the square root of 2. That's what it means, what we have there on the right hand side. So therefore we're going to have sine x is equals to the square root of 1 on top is 1 over the square root of 2. Okay, now what do we now have? Now you know the square root of 1, the square root of this, what we have in the square root, it can either be positive or negative, right? It can either be positive or negative, the answer that we have. So we're going to have the square root of this will be positive, or sine x is equals to negative the square root of 1 over we're going to have negative 1 over the square root of 2. Excuse for that. Then what do we have? Let's start with the first one. Sine half, we know that sine 1 over the square root of 2 is just the same as 45, right? So sine x is equals to 1 over the square root of 2. 1 over the square root of 2, that is just a 45. And this is in the first quadrant. Where is sine again positive? Sine is also positive in the second quadrant. So for us to find in the second quadrant, we're going to subtract from 180. 180 must subtracted by 45. I'm going to have 5. I'm going to have a 3. I'm going to have 1. So the other solution would be 135. I found for the positive one. What about for the negative one? Where is sine negative? So in the first quadrant it is positive. Let me just draw something. This is our x or y plane. We found that in the positive one, we found in this quadrant and in that quadrant. Then the other answer for sine, it is a negative. So we're going to go where it is negative. Where it's negative, it is this region and this region. Okay, so it means in that region, for us to find an angle in this region, okay, so we're going to say 180 plus, because this is 180 plus the angle that we want. Okay, so 180, but now the angle that we found, it is what? 45. Okay, it will give us one answer. Then another answer, if it falls in this region, because this is negative, so it is that. So what are we going to have for us to find the angle? We're going to subtract from 360, because we're measuring the acute angle, this one. Okay, and we're going to subtract this. So what are we going to have? We're going to have 360 minus 45. So the answer on this other one on top, we're going to have 225. 360 minus 45, I'm getting 314. So the solutions now will be x will be equals to 45 degrees, 135 degrees, you're going to have 225, and you're going to have 315 degrees. So that's how you're going to solve that one. So let's solve some more equations. What if you have sine x minus cos x is equals to 0? Okay, so what you can do here, you can change them to tan. Okay, how are you going to change to tan? You can divide throughout by cos, or 1 over cos. 1 over cos. Therefore, I'm going to have sin x over cos x minus cos x over cos x is equals to 0. Okay, now when I've got that, sin x over cos x is just the same as tan x minus cos x divided by cos x, that is the 1, is equals to 0. When I take the 1 to the other side, I'm going to have tan x is equals to a 1. Okay, and therefore x in this case it will be the tan inverse of a 1, and you know that where tan it is 1, you know that it is what? 45 degrees. Okay, now 45 degrees in terms of 1, 45 degrees is in the first quadrant. What about in the other quadrant? Where else is tan positive? All students take coffee. It is in this region, in the third quadrant. So in the third quadrant, how are we going to find angles in the third quadrant? So what are you going to do? You're just going to add that. You're going to add 180 to that. So you're going to say 180 plus 45. 180 plus 45 gives us 225. So these are the answers that we're going to have for that one. Let's solve the last question. Let's say you have sine 2x minus sine x is equals to 0. So how are you going to solve this one? Now it is the same concept, but now we've got sine 2x. What did we say sine 2x is? It's a double angle, right? So the double angle for sine is 2 sine x cos x. Now we have a minus sine x. You are going to write it minus sine x is equals to a 0. Now that we've got that, we can factorize sine x. You're going to say sine x. I'm going to remain with a 2 and a cos x. So I'm going to write that 2 cos x minus 1 is equals to a 0. Now what this means is that this is equals to 0 and this is also equals to 0. So let's just do that. So I have sine x is equals to 0. The other one it will be 2 cos x minus 1 is equals to 0. Let's start with this one. So how are you going to solve this one? Sine x is equals to 0. Okay, that is just an answer, just the way it is. But now where else is sine equals to 0? Sine any angle at also 180 is also equals to 0. Okay, so that is that. Okay, now we come to the other side. We've got 2 cos x minus 1. So 2 cos x, how are we going to solve? When you take the 1 to the other side, I'm going to have 2 cos x is equals to 1. When I divide by 2 on both sides, I'm going to have that. Then I'm going to have cos x is equals to 1 over 2. Therefore our x will be equals to cos inverse of 1 over 2. Now 1 over 2 in terms of cos, we know that it's just a 60 degrees. Now a 60 degrees is one solution. Where else is cos positive? Or students take coffee in the fourth quadrant. For us to find the other value of cos in the in the fourth quadrant, we're going to subtract from 360, right? So 360 minus 60, that will just give us 300. Therefore the solutions for x, if written in degrees, we're just going to have 0, 108. X is equals to, x in this case will be equals to, we have 0 degrees, we have 60 degrees, we've got 180 degrees, we've got 300 degrees. Okay, and they are going to give you a range. Okay, a range in terms of pi or in terms of degrees. Okay, in whichever way they want it. Now that we've talked about equations, let's talk about the last part. The last part, we're talking about sketching. Okay, so now on sketching, these are some of the important things that I want you to remember. Okay, so It's very important that you know these concepts. Okay, so we're going to talk about what we call an amplitude. We're going to talk about what we call a period. Okay, then we're going to talk about what we call a vertical shift. We're going to talk about what we call a phase shift. Basically, these are among the most important things that you're supposed to understand. Now, the amplitude is how high, or the magnitude of your function, how high it's going to go and how low it's going to be. Then the period, it is just the time it takes to complete one revolution. And because it is a time, the way you're going to find your period, it will be t is equals to 360 degrees divided by the coefficient of x, or the coefficient of your angle in that case. Okay, because it shows you now the period. So this is how you're going to find it. Or you can also write it as 2 pi, because 360 is just the same as pi, right? 360 is the same as 2 pi. So you can write it as 2 pi over b. Okay, then the vertical shift, it will be the shift in the y direction. Then the phase shift, it will be the shift in the x direction. So this is just it. So now you just have to know first the basic graphs for these different trigonometric ratios. So you have to know the graph of f of x is equals to sine x, f of x is equals to cos x, and f of x is equals to tan x. So let's start with sine x. So for sine x, how is it going to be? Let's say this is our graph. Okay, let me just draw all of them in advance. Let's say those are our graphs. Then for sine, so the amplitude, let's take as 1 and 1. So the sine graph, the cosine graph, and the tan graph, they all alternate between 1 and -1. So 1, -1, 1, -1, unless something happens to the graph. Okay, which we'll see later on as we start solving questions. Now this is just a general of how a sine graph looks like. So the full revolution is known at 360. Half of 360, we know that it is 180. Between 0 and 180, you know that it is just a 90. Between 180 and 360 is just a 270. Okay, now for a sine graph, it always starts at 0, 0. So let me say this is 0, 0. It will pass through 180. It also going to end at 360. So if it's a positive sine graph like this one, we've got f of x is equals to sine x. Okay, excuse on that one. So we've got f of x is equals to sine x. So what are we going to do? So it means it's going to pass through at 90 and at 270. So it's going to go up, come down like that and like that. Now you're able to see that it has come up and it has come down. That is a complete revolution. Okay, now if it was negative, let's say it was negative sine x. If it was negative, therefore the points are going to change. It's going to come down and go up. So it's going to pass through like that. Okay, so that's how it's going to move. Okay, so for a positive one, we've said it's going to move, passes through that point and passes through that point. So it's going to be something like this. Okay, so that is the general graph of a sine, a sine graph. Now let's come to a cosine graph. So how does a cosine graph look like? So this is 360, this is 180, this is 270, this is a 90. So a cosine graph is not very much different, but for it, it's just going to start at 1,1, or let me say 0,1, and it's also going to end at 360. So these 2 points. So it means it's going to pass through 90, passes through 180, and it passes through 270. So how is it going to go? It's going to go like that, move like that, and move like that. Okay, so that is it. That's how it's going to move, like that, and it passes through there. Okay, so that would be our cosine graph. If it was negative, let's say it was negative cos x, so it means it's going to start from this point and end on the other point. So it means it's going to pass through this point, pass through that point, and pass through that point. So it's going to be something like that, moves like that, passes through that point, and go like that. So that would be the negative part of it. Okay, so this is a general graph for a cosine graph. Now let's also talk about a tan graph, although most of the time you're not going to be asked about a tan graph. Okay, so let's say this is 90, this is 180, this is 270, this is 360. So for a tan graph, it's a bit unique because for it has got asymptotes. An asymptote, is just a part on that graph which should not be touched. Okay, you know that. So what are we talking about? We're talking about, so there will be an asymptote at 90 degrees. There will also be an asymptote at 270 degrees. So how is a graph like? So for the graph of tan, it's going to go up, not touching that line. So it's also going to come from this point, but it's going to pass through 180 and follow this asymptote. Then the other one is going to come from this side and it's going to go like that, not touching those points. So basically this is whatever they're going to give you are just going to be shifts and change in period. Okay, so let's solve some questions. So what can we start with? So let's say you have f of x. Let's say f of x is equals to 2 sine x. So how are you going to solve this one? So you draw your graph. Let's draw our graph in advance. Okay, so for this one, let's say they've asked us to find the period, the amplitude, and everything, and the vertical shift if we have. So for this one, we don't have any vertical shift. A vertical shift will be something like a 2. What a 2 means, it means you've shifted the where the graph is starting from. If it's a sine graph, it starts at 0,0, but because you've added a 2, it means it's going to shift 2 units. That's where it's going to start from. Okay, it's a shift in the right direction. So that's a vertical shift. But in this case, let's say we don't have a vertical shift. So we're going to find the amplitude. The amplitude will be the coefficient of the function. In this case, it will be a 2. And the way I find the amplitude is the absolute value of that number. If it was a negative, it's still going to be a positive. So in this case, we're just going to have 2. Then the period we said it is 2 pi or 360 divided by b. B is the coefficient of x. Now the coefficient of x in this case is just a 1. So we're going to have 2 pi over 1, which is just the same as 2 pi. Okay, the vertical shift is equals to 0. The phase shift is also equals to 0. So how are we going to graph our graph. So we found the amplitude to be 2, so it will be alternating between 2 and negative 2. Then we've got 90, 180, 270, 360. So we said, how does the sine graph looks like? It always starts at 0, 0, which is that point. It's going to pass through 180. It's also going to pass through 360. Now, because look at it's positive, the value of x is positive, and the value of the function itself is also positive. So what are you going to do? You're going to go up, pass through 90, and down, pass through 70. So you're going to go like this, like that, and like that. So that's how you are going to solve this one. Let's introduce the shift. Let's say you have f of x is equals to cos, let's say cos x plus a 2. So how can you solve this one? Allow me to draw my graph in advance. Let's say this is the y-axis, this is the x-axis. Okay, now what are we supposed to do? So let's find the amplitude. Now the amplitude, we said, is just the absolute value of what we have. Now the amplitude in this case is just the absolute value of 1, which is just a 1. Then the period is equals to, we said period is just equals to 2 pi over b. B in this case, the coefficient of x, you're able to see is just a 1, so the period is 2 pi or 360. The vertical shift, now you're able to see that we have a shift of 2 units, so 2, the vertical shift. The first shift, it is 0. Now because we've got 2 as a first shift, so it means to the amplitude we're supposed to add and subtract that 2. Okay, now if we add, because you know that initially it's supposed to be rotating between 1 and 1, so it means to this one we're supposed to add 2, because we shifted the graph 2 units on top. So because if we add 1, if from 1 we add 2, we're going to end at 3. Then from negative 1, when you add 2, we're going to end at 1. So it means our graph is going to be alternating between 3 and 1. So what do I mean? So initially the amplitude is supposed to be at 1, but now because we have a vertical shift, we're going to add plus a vertical shift of 2, which is going to be 3. But now on the lower limit, we are the negative 1. We're also going to add a 2 to it. We're going to have a 1. So this is how our graph now is going to be, you know, moving. So we're saying we have an amplitude of 1 and a 3. Now that we've got that, let's say this is 1. Let's say this is our 3. Then between 3 and 1, you can add the 2 and divide it by 2. 3 plus 1, that is just a 4. A 4 divided by 2, that is a 2. Or you just find the middle point. The middle point is to be a 2. So this will be the middle point. So therefore our graph is going to be alternating between these points. So now how are we going to graph? So we're going to say 360, that is the period, or 2 pi. Let me write in terms of pi. So 2 pi. Now the half of pi, you know that is just pi. Then between 0 and pi, you know that it is half of pi. Half of pi is just pi over 2. Then to find the other one, you're going to multiply the first one by 3, or what you're going to do is add pi plus 2 pi, then divide by 2. So what do we have? We're going to have 3 pi over 2. Now that we've got that, what are we supposed to do? Now what we are supposed to do now here is just to graph. Okay, so now look at the value of the function. It is cos x plus 2. So the value of the function itself is positive, so it means we are moving in the positive cosine direction. Okay, so you know that the cosine direction always starts at the maximum point and ends at the other maximum point. So how is it going to move? It's going to pass through this point, pass through this point and pass through this point. So how is our graph going to look like? It's going to move like that, pass through this point, pass through that point, and like that. So that will be our graph, and that's how we're going to graph that one. So let's solve another question. Let's say you've got y is equals to -3 plus 4 sine x. Okay, so what are we going to do? What is our amplitude? What is our vertical shift? So our amplitude in this case, you're able to see that the coefficient of the function itself, it is positive 4. So we're going to find the absolute value of 4, which just gives us a 4. Okay, then we're going to also find the period. We said is t, so it is 2 pi over b. B is the coefficient of x. Now the coefficient of x here is just a 1, so the period is just going to be 2 pi. Then the vertical shift, you're able to see that we have a -3, so the vertical shift is a -3. The first shift, it is a 0. Okay, now that we've got that, we've got an amplitude of 4 and we've got the vertical shift of -3. Then what did we say? To the amplitude, you're going to add and subtract the -3 that you have. So you're going to have 4 minus 3, and you're going to have -3, or let me say -4 minus 3. Okay, so these are the two limits. 4 minus 3, it is a 1. -4 minus 3, that is a -7. So these are the 2 points that we are going to have. So we have everything that we need to graph our function. So now we put our period. We said it's ending at 2 pi, so this is 360. So the amplitude, you've said we've got 1. Okay, just for measurement's sake, let me put my 1 to be there, and let me put my -7 to be there. Okay, now what are we going to have? So we can demarcate this one. Now what is between 1 and -7? So I can add 1 plus -7. That will just give me 1 minus 7, that is just equals to -6. -6 divided by 2, that is like a -3. So what is in between is just a -3. So let's say our -3 is there, and I indicate like that. Okay, so now what will be our points? We are saying this is a sine graph. Okay, sine graph always starts in the middle. Okay, so it's going to start at this point. Then a sine graph always passes through 180 and 260. That's where it's going to end. So how are we going to do this? So it means it's going to go up because it's positive, and it's going to come down like that. So how is our graph going to look like? Goes up, comes down, and like that. So that will be our graph. Okay, so that's how you are going to solve it. Let's solve another one. Let's say you've got f of x is equals to sine 2x. So how are you going to do that? Now you're able to see that the period has changed. How has this period changed? You're going to say period is equals to 2 pi over b. Okay, so we've got 2 pi divided by b. B in this case, it is what? It is the coefficient of x. The coefficient of x in this case, it is a 2. So we are dividing 2 pi divided by 2 2. You know that the 2 and the 2 divide, they're just going to remain with a pi. A pi is just the same as 180. Okay, so how is our graph going to look like? Let's say this is the y-axis, this is the x-axis. So the period, okay, the amplitude you're able to see is just the 1, and then like that. Now the period has changed. It's now 180 to take a full revolution. So now the half of 180, you know that is just a 90. Now between 0 and 90, you know that it is a 45. Then between 90 and 180, you can just get 45 multiplied by 3. I'm going to get 135. Now what is going to change? Nothing. Everything will be the same because it is positive. It's going to pass through 0, 0. It's going to pass through this middle point and through the last point. So because it's positive, it's going to go up and come down. So what do we have? It goes up, comes down like that, and that's how you are going to find that. Okay, so let's solve the last one. What if you have a phase shift? Okay, now if you have a function with a phase shift, let's say f of x is equals to, let's say, sine, let's say x plus pi. Okay, so what you have in the bracket is what we call, because the value of x now, you've added it, you've shifted it. How have you shifted it? You've added a pi to it. So what you're going to do, you're going to equate this to be 0. So you're going to say x plus pi is equals to 0. X will be equals to, when the pi goes to the other side, is negative pi. This is the phase shift, and the phase shift tells you where your graph is going to start from. Okay, so that is the phase shift. Okay, so our graph is not going to start at 0, 0, but at negative pi. Okay, then let's find the period. The period, it is the time to complete a full revolution. The period we said is 2 pi over the coefficient of x. Now the coefficient of x here is just a 1, so period is 2 pi. So now the graph is starting at here and it's supposed to end after 2 pi. So what will be, now where's our graph going to end? So it means to know where the graph is going to end, we are going to add a 2 pi to negative pi. So what are we going to have? We're going to have negative pi plus a 2 pi. And when you do that, you know that you're just going to have a pi. Okay, so it means our graph is going to start at negative pi and it's going to end at pi. Okay, now that we've got everything that we have, what do we do? Okay, let's say let's graph it like this. So let's say this is the y-axis, this is the x-axis. Okay, so how are we going to do it? So we're going to say, okay, because it's going on the other side, it's because, let me just draw my graph nicely. Okay, so because we've got an amplitude of 1, allow me to write my 1 here and negative 1. But now we've said this graph is starting at negative pi, so let's say negative pi is here. Okay, so between 0 and negative pi, I have negative pi, or the half of that is negative pi over 2. Then on the other side, it's also going to end at pi. Now between 0 and pi, it is just the half of that, which is pi over 2. So now that this is what we have, so how is our graph going to move? So it means our graph is going to be moving between 1 0, 0 and this point. So now what do we do? Okay, so what we now do is that because it's a sine graph and it is positive, it's going to go up and come down. Okay, so what would be the nature of this graph? So it always starts at this point. Okay, so it goes on top through this point. Okay, so it's going, for this one, it's going to pass at 0, 0 because that's like the middle point. Then it's going to come down here and it's going to end at pi because that's where the period is. Okay, so how is our graph going to look like? Goes up, passes through that point, and goes like this. Okay, so this is how the how you are going to graph this one. Okay, so that's all about trigonometric functions. We've talked about everything. Then in case you are stuck about anything, you can still watch our trigonometric playlist. We are going to have everything, and please don't forget to subscribe. See you in the next session.